Hi, Micah. Thank you for your question. My name is Aaron. I'm a tutor in geometry, pre-calculus, as well as calculus. So let's try and tackle this problem. Usually what I do with word problems is that I try and draw out the situation that they're describing. And that helps me visualize it and also gives me a way to actually come up with a solution a little easier. So what I've drawn here is I have the power plant, 50 miles to the east of that power plant, and then 6 miles north from the freeway, I have the town of Cortez. For the town of Joplin, it is 43 miles east of that same power plant, and then 10 miles to the south of that freeway. And what they're trying to do is place a single junction station that would connect to both Cortez as well as Joplin to supply power to both of those. And this junction city will be along the freeway that connects both of these towns. So what they have told us is that the distance between the power plant to this junction point is x. What they want us to find out is various formulas as a function of x for find the distance between that same junction point to both of those cities or each of those cities individually. So what we want to realize for this is that what we're trying to solve for is the distance between P to, say, at the town of Cortez, and then the distance between P and Joplin. So what we need to do to calculate that is actually use our Pythagorean theorem and calculate that hypotenuse length between P and Cortez and then P and Joplin. And that will give us the power line needed from the junction point to each of those towns. So that will solve problem 1 and 2 for us. And the formula for the total length will be the sum of all of the wires x, the wire from P to Cortez, and the wire from P to Joplin. And subsequently, we can also graph this function and see what value of x will minimize the total length of wire required. And this, as you can see, is a very, very applicable problem. This certainly does come up in the real world very often. And we want to find the right point on the right location to place this junction to be able to minimize the amount of wire required. Let's go ahead and jump into this. So what I've done is broke the problem up in 2 parts. Part 1 is to try to find the distance from the junction point to Cortez. Part 2 is to find the same junction point to Joplin. So the key to note here is that if the entire length from the power plant to where the right angle going up towards the north to hit the town of Joplin is 50 miles, the distance from P to that same right angle is 50 minus x. And that gives us one of our side lengths. And the other side length is 6 miles as given by the problem. And using that, we can use the Pythagorean theorem, which is square root over a squared plus b squared. That will give us the hypotenuse angle from P to Cortez. So knowing a is 50 minus x, b is 6, we can actually plug that in and get our equation for getting the distance between P to Cortez. So that'll be this right here, the square root over 50 minus x squared plus 6 squared. And then we can do that same thing for Joplin, which will be if our entire length from the power plant to the right angle before we can go south 10 miles to hit Joplin, and that distance is 43 miles. The distance between the the distance between the junction point to the right angle is 43 minus x. Once again, then we have both of our values that we need to get our hypotenuse. And I realize now I have a typo here. This should say b equals 10, because that's 10 miles south from that junction point. And plugging this in, we will get our equation for the distance from that junction point to the city of Joplin. Now the third question is, how do we get what the total amount of the cable required? So that's going to be the sum of the wire used from the power plant to the junction point, and then subsequently the 2 lengths of power line from the city, from that p value to Cortez, and the junction point p value to Joplin. So we can basically sum all of these 3 together. The first equation we had above, the next equation, and then that value x itself. The last part of this is to graph it. So I've gone ahead and done that. And what we can see is that at a minimum of about 41.22, which is our junction point, that will give us the minimum amount of wire required to connect all of these three towns, the two towns to the power line, and then to that power plant itself. So do reach out if you have other questions. And also, I would love to help more. If you have any other questions about any problems you might have, feel free to reach out to me. Thanks.